Hello everyone, this is Maurizio, editor-in-chief of Power Electronics News and Embedded.com, and I am here at Electronica, showing in Munich, in this wonderful location. And I am here at the Allegro MicroSystems booth, and I have the pleasure to be here together with Mike Doogue, Senior Vice President, CTO at Allegro MicroSystems. Hi Mike,
Hi
thanks
there.
a lot for being here. How are you?
Thank you for having me. I'm doing well.
Good? So how is it going? Everything is good?
It's always exciting at Electronica.
Yeah, indeed.
It's such an active show and so many customer meetings. We're always thrilled to be here.
So Electronica is one of the most important trade shows showing for the electronics industry. So what's news from Allegro MicroSystems? What key technology are you showcasing today?
I hope you have time because we're announcing a lot of different things today. So the theme for us this year, we're a leader in both sensors and power ICs, and the theme for us at this show is sensors and power reimagined. So we are introducing various new sensor technologies and power technologies at the show. In the area of sensors, we're proud to be talking about some of our new inductive sensors as well as our ExtremeSense TMR sensors. And in addition, we have a full range of newer current sensors that we're showcasing to customers that come by the booth. In the area of power electronics, it's really all about 48 volt motor drivers and regulators. So we'll talk some more in the next few minutes about those, as well as our high voltage gate drivers for gallium nitride and silicon carbide transistors. So we have a lot of great innovations happening, and we're talking about them extensively at the show.
Yeah, good. So let's talk about 48 volt system. So the demand for efficiency, the demand for cost, of course, cost effectiveness, so are driving so the adoption of 48 volts in different markets, so such as automotive, such as data centers, and so on. So if we talk about features, so I can mention high breakdown voltage, lower drain to source resistance, that means resistance RDS on. So how these parameters would translate into a benefit for 48 volts? And any updates from your SG8 semiconductor process technology?
Great question, and you obviously know about Allegro based on the wafer technology question. So at the foundation of our solutions for 48 volt systems is our wafer technology.
Yeah.
And many years ago, we invested in a BCD technology that's capable of handling 110 volts, has excellent RDS on, and it's really ideal for 48 volt applications. As we came to market, some of the first applications we looked at were both fan driver and motor or pump driver applications. In the area of data center, that's where we really saw some early adoption of 48 volt fans and 48 volt buses. But Allegro really as an automotive first company with around 70% of our sales in automotive, we knew 48 volt would come to the car. It has come to the car. It will keep coming to the car with a greater pace of adoption in the future. And we're seeing it in ADAS systems, whether that's steering systems, we're seeing it in thermal management systems and EVs. And I think the use case is a bit different depending on the application. Certainly when you go to 48 volt and you're talking about a pump or a motor, they can use less copper in the windings, that's lower weight, leads to optimum efficiency. And with some of the technologies we bring to the table, whether it's our fan drivers or our pump drivers for cooling systems, particularly in cars, we do have superior efficiency compared to competing solutions. That can be longer range in an electric vehicle. And we're really quite excited about everything we're bringing to the table with our 48 volt solutions.
So a big topic is wideband gap, gallium nitride and silicon carbide, probably my favorite topic. So what about GaN and silicon carbide for electric vehicles, for example, renewable energy, consumer? Do you see a competition between GaN and SiC? So in the future, probably not now. So what's your comment?
That is a lengthy topic here. I'll try to keep it brief. First and foremost, we see both GaN and SiC being adopted, and it really depends on what market or industry we're talking about. We at Allegro have high voltage gate drivers, which are truly unique. And they're unique in the fact that they combine an isolated power supply and an isolated gate driver into a single package, somewhat random. The package is on the wall here. It's a very unique solution that customers love because it has high power density and high efficiency and can work through its programmability with a wide range of transistors. In our family of products, we started with a GaN driver. We're actually just now releasing or talking about our silicon carbide-based high voltage gate driver here at the show. What we see, you look in solar, you look in data center for titanium grade power supplies. Certainly in these various applications, they value efficiency, they value high power density. GaN is there already. In the automotive world, and all of our solutions are automotive qualified, we're actually working, whether it's in an onboard charger or other applications, with customers who are implementing silicon carbide today and looking to the gallium nitride space for solutions of the future. Again, loving the power density. We've worked with one large automotive customer who was able to shrink their onboard charger substantially, not just because of Allegro, but with the enhanced power density, the integration we offer in our packaging. They had a lot of benefits switching over to GaN and SiC, and we're here to enable that transition.
Thank you. So, Mike, my last question. Let's talk about extreme sense TMR technology. So, what about our advancement in terms of magnetic sensitivity, thermal stability, will be benefits for applications such EV, electric vehicles, and renewable energy systems?
Love the question. So, I've been in the magnetic sensor space for over 20 years. Allegro's proud to be the #1 provider in terms of market share of magnetic sensors. And the market today is still mostly Hall effect sensors, but with Allegro's extreme sense TMR technology, we're seeing a lot of interest from customers for various reasons. So, compared to a Hall effect sensor, these TMR sensors, as you mentioned, they're more sensitive. They also offer higher resolution. So in a motor position control application, having higher resolution means you can have a higher performance motor. It can be more efficient, it can be quieter, it can have less vibration. In the area of power electronics, we're excited about using the TMR in current sensors. There's a lot of benefit that TMR can bring to the table. One of them is actually speed. So Allegro was first to market with 1 megahertz current sensors using Hall technology. We recently released 5 megahertz sensors, and we have said publicly before we're working on 10 megahertz TMR sensors. In your favorite area of GaN and SiC, one of the problems our customers have is protecting the transistors during short circuit conditions. With our very high speed current sensor ICs, some of them have an integrated overcurrent comparator. Not only do you have the high resolution of TMR to do control on your power loops, but in the event of an overcurrent condition, you have a very rapid response and you can protect the components. One of the biggest barriers to adoption, particularly of GaN that we've seen, is that you have to have a very fast response in an overcurrent condition. We're bringing those types of solutions to the table with the extreme sense technology.
Good. So, Mike, wonderful conversation. Thanks a lot for your time.
I appreciate it.
Thank you. Have a good day at Electronica.
I will. You too. Thank you.
Thank you. Thank you.